So let's start with vector analysis. So let us first see detailed syllabus for this particular chapter. Note down the syllabus. What topics we are going to study in vector analysis. So first we will talk about coordinate system. Coordinate system. So we will first see Cartesian coordinate system. Here coordinates are x, y, z. Then we will talk about spherical polar coordinate system. Here coordinates are r, theta, phi. R, theta, phi are spherical polar coordinate system. Then we will talk about cylindrical coordinate system. Here coordinates are r, phi, z. R, phi, z. So first we will define these coordinate system. And in this we will also talk about transformation of a vector from one system to other system. Transformation of a vector from one system to other system. So we will transform from Cartesian to spherical or spherical to Cartesian, Cartesian to cylindrical or cylindrical to Cartesian. So that will be the part of coordinate system. Then we will talk about gradient, divergence and curve, and we will see their applications also. Gradient, divergence and curve. And these are called the first derivative. These are called the first derivatives. We will also discuss some second derivative, mainly 5 second derivative, some second derivatives. Then we will see what is line integral, then surface integral, and volume integral. So we will first define it and then you will see how to calculate it in different coordinate system. Okay? So if you know these integrals, now we will define fundamental theorem of first is gradient. Fundamental theorem of gradient. Then we will discuss fundamental theorem of divergence. And that is also called as Gauss divergence theorem. Gauss divergence theorem. And third one is fundamental theorem of curve. And we will talk about Stokes theorem. So you will see using these theorems, you can simplify your calculation. Sometimes it is easy to calculate volume integral than closed surface integral or closed line integral than surface integral. So we will use this theorem to simplify our calculation. Clear? And lastly, we will see another theorem that is called as Green's theorem. नोट हो गया? So now let us first see what is a vector. What are the vector quantity? So vector has magnitude, direction, and they obeys vector law of addition. So you should write that vector quantity have magnitude, vector quantities have magnitude, direction, and they obeys vector law of addition. Vector law of addition. We will discuss what is vector law of addition. So in general, how to represent any vector A is represented by this symbol. This is vector A. Like electric field, magnetic field, force, acceleration, velocity. So that is the symbol. And its magnitude is represented by mod A. Magnitude is represented by mod A. And unit vector along A is given by A cap. So we will use this notation. Unit vector along A is given by A by mod A. And we represent any vector. Let's say this is vector A. That is how a vector is represented. So this is head of, we call this point as head and this as tail of the vector. This length represents the magnitude of vector A and unit vector is given by A cap, that will be in this direction. Okay? So that is the representation of a vector. It have any magnitude or it can have any direction. Now, what are the 4 basic operations that you can perform on a vector? So there are 4 basic operations. So what are those basic operations? There are 4 basic operations that we can perform on a vector. So first is vector addition. Vector addition. If let's say if you have 2 vectors A and B, then how to show this A plus B? And let's say if I represent this by vector A, this is some vector A and this is some vector B. And we want to add this vector. So you have to use the vector law of addition. So A plus B, if you want to represent, so we will first show this vector A. This is head of the vector and this is its tail. So if you want to add A plus B, so just place B vector here. And so tail of B is placed at head of A and then connect tail of A with head of B. So this will be the vector R and that is given by A plus this will be vector A plus B. We can also represent B plus A. In same way, you can represent B plus A. So we will first place B vector. This is B. This is its tail and this is head. And again, you have to place A vector, tail and head, and then connect this point. So that will be resultant R will be B plus A. Okay. So, and you will see here that A plus B is B plus A. So we say that vector addition follows the commutative law. This follows the commutative property or commutatively. That A plus B is B plus A. In same way, you can show that if you have 3 vectors, A plus B plus C is A plus B plus C. It's an introductory lecture, so I will first introduce the different things and then we will talk about coordinate systems. So you must know the basic part also. Okay? So this is, it also holds the associative law. Let's see what will be, how to find A minus B. If you are multiplying a vector by minus A, so what will happen? Only its direction will change. So you can represent minus A vector by this. This is minus A vector. And this length will give you magnitude of minus A. This will be its magnitude, and this will be its direction. So this you can write as simply vector addition with direction of B change. A subtraction means addition with direction of B has been changed. So if it is a vector A, so let's say this is vector A, then this will be vector B minus B. So this will be the resultant. R is A minus B. So you can also see difference of two vectors with same property. A plus B. So A minus B is A plus of minus B. Clear? The same addition, subtraction is same as addition. A minus B is A plus minus B. ठीक है? But for calculation purpose, what we will do, if you want to find the resultant vector, we will use the component form. So resultant in terms of component form. That is the easiest way. So let's say if you have a two vector that is given in xy plane, and if we assume unit vector along x is given as x cap and unit vector along y is given as y cap, and there are n number of vectors, let's say vector A, vector B, vector C, and so on, and you want to find the resultant, what will be vector sum A plus B plus C and so on? What will be the vector sum? So easiest way is resolve this vector in xy component. So you have to find all Ax component here. What will be component Ax, Bx, Cx, and so on? And this component may be in x cap or may be in y cap. I'm writing in general it is x cap. So, and what about component along y cap? This will be Ay, By, Cy, and so on. So you have to write resultant Rx. This R is this vector. R is A plus B plus C. So you have to see the resultant X component. So then when Ax, Bx, Cx, they are in the same direction, you have to add the magnitude. If vectors are in opposite direction, you have to subtract. So in that way, if you find, so I am writing in terms of plus only, it may be minus also if they are in opposite direction. Ax plus Bx plus Cx and so on. And similarly, we will find Ry is Ay plus By plus Cy plus and so on. So resultant vector can be represented as simply Rx, R cap plus Ry, Y cap. This is the resultant vector. Yes or no? So finally, you have represented this vector like if it is x cap and this is y cap, and now I got this vector. This is vector R. So in component form, you will see this component is Rx and this component is Ry, where Rx and Ry you can calculate. So n number of vector is given, resolved in component form, x and y, and then write their resultant. And we will discuss that if theta is the direction, if you know Rx and Ry, So magnitude of r will be given by under root rx square plus ry square, and theta is direction is given by tan inverse ry by rx. So if you know component x and y, you know the magnitude of the resultant and you know the direction with respect to x. This theta is direction with respect to x.
वेक्टर की जो इंक्लिनेशन है दूसरे वेक्टर के से वो चेंज होगी, बिल्कुल ऑपोजिट भी नहीं, इंटरमीडिएट क्या वाला फॉर्मूला यूज करते हैं
Which
जो आपने
whatever be the direction that you are talking about, some resultant vector.
So if the a vector is suspended intermediate, neither 180 degree nor 0 degree, it's not parallel to the other vectors.
It's no, I'm not getting your point.
If direction would be intermediate of the
0 to pi. No, what you are saying, let's say this is x and y, and where is the vector?
is
B is like this. Let's say this is B,
is perpendicular.
this one, no?
Can still apply, sir.
You can always apply, then you have to see this will be the angle. So if you see the component, one component in this direction, one component in this direction. If it's, you will see this one component in this direction, one component in this direction. That's why I told you that you have to see the direction also. So if let's say AX is in this direction, BX is in opposite direction, so BX you have to write with minus sign. So that this is always valid. Clear? Direction may be different. Whenever I am writing plus, depending on direction, if they are in same direction, you have to add. If they are in opposite direction, you have to subtract. Clear?
ऐसी क्वांटिटी है मतलब जो नेगेटिव रिएक्शन रखती है लेकिन हम वेक्टर में इसको बोला करते हैं.
अब ऐसे करोगे करंट, जो करंट इन अ वायर, इन जनरल करंट इज अ वेक्टर क्वांटिटी. अगर आप सरफेस करंट, वॉल्यूम करंट की बात करोगे तो वो वेक्टर क्वांटिटी होती है, लेकिन जो हम वायर्स में जहां केसीएल अप्लाई हम कहते हैं ना करंट की डायरेक्शन ये, बट दैट इज अ स्केलर क्वांटिटी. ठीक है. नाउ सेकंड थिंग इज multiplication by a scalar, that I have already discussed. Multiplication by a scalar. So let alpha be some scalar. So you can multiply a vector by some scalar alpha. If alpha is positive, direction remains same. Direction remains same. Only magnitude changes. Only magnitude changes. And if alpha is negative, then direction and magnitude both changes. Direction and magnitude both changes. Okay. So if you are multiplying, let's say +1, so magnitude will remain same, direction will remain same. If you are multiplying with -1, magnitude is same, direction is opposite. If it is 2a, direction will be doubled. If it is alpha is 1/2, magnitude will be half. So that you know. Next thing is that you must know is the dot product. Dot product of two vectors. dot product of two vectors. So assume this is vector A and this is vector B, and theta is the angle between two vectors. Theta is angle between two vectors. So first you should know what is angle between two vectors. Angle between two vectors. This angle is theta. How you will identify angle between two vectors? So definition is, you have to always use this definition. It is the smaller of two angles, smaller of two angles between vectors if they are placed tail to tail. It is the smaller of the two angles between vectors if they are placed tail to tail. So I will use this definition to identify the angle between two vectors. So for example, here I have placed these vectors. This is tail of vector A and this is tail of vector B. Tail of A and tail of B. So they are placed tail to tail. So there is two angle between these two vectors. One angle is this, another angle is, this is what? 2 pi minus theta. So always see which one is the smaller. That is the angle between two vectors. Whenever I say angle between two vectors, by definition, it is the smaller of the two angles when they are placed tail to tail. So theta is the angle between two vectors. Whatever be the case, let's see if I am telling you this is vector A and this is vector B. Let's say this angle is 70 degree. This angle is 70 degree. So this is the angle between two vectors because one angle is this, another angle is this. So this is the theta. Theta is this particular angle. If I consider this is vector A, this is vector B. Now this angle is 70 degree. This is given. So what is angle between two vectors? What will be angle between vector A and B? So let's place tail to tail. So extend this vector. This is vector A. Now extend this vector. This is tail of this vector. This will be vector B. This. So this angle is 70 degree. Now you have to see angle between two vectors. One angle is this. This angle is what? 110. 110. Another angle between these two vectors is this whole angle. That is 250. This is 250. So what will be the angle? This is the angle theta. This is the angle between two vectors. So you have to always identify angle between two vectors. When I am defining dot product, so I am first defining what is angle between two vectors. When they are placed tail to tail, that is the angle theta. Clear? So now this A dot B is given by this is given as mod A mod B cos theta, and that is a scalar value. That is a scalar value. So geometrically, what does this represent? Let's say mod A is the length of vector along A. Now mod B cos theta is, this is projection of B along A. What will be this projection? Mod B cos theta. In triangle rule, let's consider this triangle. So what will be projection of B along this direction? Cos theta. And in perpendicular direction, projection is sin theta. We will use this rule again and again. If you have a triangle and you know angle between two lines, so along the line projection will be cos theta, and a line perpendicular to this will be a sin theta. Similarly, if you write B dot A, so that will be mod B mod A cos theta, or you can say mod B into projection of A along B. Projection of A along B. So if this is B, this is A, this angle is theta, this angle is 90 degree, and this is vector B. So what will be this projection? This is mod A cos theta, and in perpendicular direction projection will be mod A sin. So whether you are taking projection of B along A or projection of A along B, so A dot B is equal to B dot A. This holds the commutative law. This also holds the distributive property. So A dot, if you have B plus C, so that is given by A dot B plus A dot C. That is distributive property. So dot product follows the distributive property. If vector A is perpendicular to vector B, then A dot B is 0. If A is parallel to B, then A dot B is simply just multiply their magnitude, mod A into mod B, because cos 0 is 1. Here theta is 90 degree, here theta is 0 degree. Okay? So that is the dot product of two vectors. That is third operation. So we will use these properties to check whether vectors are perpendicular or parallel to each other. Okay? Now next one is, fourth one is cross product of two vectors. Fourth one is cross product of vectors. Cross product. So again, if you have a, let's say this is vector A, this is vector B, and this is the angle between two vectors. So this projection is given by mod B sin theta. So A cross B is given by mod A mod B sin theta, and n cap is direction of A cross B. A cross B, and this cross product is a vector quantity. It's a vector quantity. So what will be direction n cap? How you will check n cap direction? So you have to use right hand rule. We call it as right hand rule. You will see in EMT at least 8 times I will apply right hand rule in different form. So first time I am introducing the right hand rule, and this is for cross product of two vectors. Okay. So what is right hand rule? Use your right hand and move your fingers. If you have to find direction of A cross B, move your fingers from A to B via a smaller angle, because angle is, this is the smaller angle, so A cross B. Then thumb will give you direction of A cross B. So A cross B is outward. And if you have to find B cross A via a smaller angle, inward. So that is the right hand rule. So you can write, use your right hand and move or curl your fingers from A to B via smaller angle, then thumb will give direction of A cross B. Thumb will give you direction of A cross B. So n cap is direction of A cross B, and n cap is always perpendicular to the plane containing A and B. So n cap is always perpendicular to the plane containing A and B. Whenever there are two vectors, they lie in a plane, and n cap will be perpendicular to that plane. Clear? So here A cross B direction is outward. So in this case, A cross B, this n cap is outward. If you have to see B cross A, then n cap is inwards. So here they does not follow the commutative law because A cross B is minus of B cross A. But they follows the associative law A cross distributive law. This is A cross B plus A cross C. So if you have two vectors A and B, then we can find area of this parallelogram generated by A and B. This vector is these lines, this is parallel to A and this is parallel to B. So geometrically, mod A cross B is the area of parallelogram generated by A and B. Mod A cross B represents the area of this parallelogram. If A is perpendicular to B, then A cross B is simply mod A mod B sin 90 is 1 and its direction is n cap. So if A is parallel to B, so theta will be 0. So A cross B is 0. Okay. So these are the four basic operations that you can apply on vectors. Now we will talk about coordinate system. So till now I have represented vector A by this symbol only, magnitude by mod A and direction by A cap. But if you want to represent this vector, you need coordinate system. So we have three coordinate system. First is Cartesian coordinates. We will first see how to represent this vector in a Cartesian coordinate system. Coordinate system. Coordinates are x, y, z. So you know about Cartesian coordinate system. And in this coordinate system, vector A is represented by AX, x cap plus AY, y cap plus AZ, z cap. This is vector A. So it has three components, AX, AY, AZ. and x cap, y cap, z cap are unit vectors. X cap, y cap, z cap are unit vectors. So we have three mutually perpendicular axes. This is x, this is y, and this is z. And this is the origin. This is the origin. So we have three mutually perpendicular axes, x, y, and z. Now we have to show how we will define the directions of unit vector, or what are the unit vectors. Unit vectors. So magnitude is 1. And its direction is always, means positive direction is always in the direction of its increasing coordinates. Positive direction of unit vector is in the direction of their increasing coordinates. For example, in this x is increasing, so this direction is positive x cap. This direction is positive y cap. So this direction is positive z cap. So negative direction is opposite to it. So you know this is minus x cap, this is minus y cap, and this is minus of z cap. Okay? So we know the direction of unit vector. Now ax component is along x cap. So let's say component along x cap is ax, component along y cap is ay, and in xy plane component will be ax and ay. In xy plane component is ax and ay, and in z direction component is az. This component is az. So you can represent vector A by this. This is the vector A. And this vector A has three components: ax along x cap, ay along y cap, az along z cap. And unit vector along A is given by A cap. So that is the representation of vector A in Cartesian coordinate. So as I have discussed that when you have to find line integral, you have to find, let's say, E dot dl. So you must know what is dl vector. If you want to find line integral, you have to know dl vector. If you want to calculate surface integral, then you must know what is dA vector. This is known as area element. And if you want to find volume integral, you must know d tau, volume integral. So in these three coordinate system, we will also see how to write dl, dA and d tau, so that you can calculate line integral, surface integral and volume integral. So let us first define what is the position vector. What is position vector. So position vector is R. R is the position vector. So in vector notation, each point is represented by its position vector. So let's say this is X cap, this is Y cap, and this is Z cap. And you have some point P whose coordinates are X, Y, Z. And this point P is represented by its position vector R. So you have connected point P with origin. Each point P has its own position vector depending on its coordinate X, Y, Z. So position vector R is given by X, X cap plus Y, Y cap plus Z, Z cap. And you will see in component form, if you want to see this, this is X, this is Y, and this will be Z. This point P, its position vector is represented by R vector. So this component is X, this component is Y, this component is Z if its coordinate is X, Y, Z. So R vector is given by this relation. And what will be magnitude of R here? This length from origin to point P is represented by small r vector, and that is given by X square plus Y square plus Z square. Okay? Then what will be unit vector along this R cap? So this unit vector is given by simply vector R by mod R. Unit vector along R cap is vector R by mod R. Clear? Now we have to see what is DL vector. This is called as infinitesimal displacement vector. This is DL vector, infinitesimal displacement vector. DL is infinitesimal displacement vector. So how you will define DL vector? Let's say you are at point P whose coordinates are X, Y, Z. And if you change X, Y, Z by elemental change, X by dx, Y by dy, and Z by dz. So X changes by dx, Y changes by dy, and Z changes by dz. So you will see, you will move from point P to some point Q here. Let's say this point is Q. So change in position vector R is R plus DL vector. This is DL vector. So this is the infinitesimal change along the r cap direction. So this is the elemental change, and that change is represented by dl vector in r cap direction. So at point P, coordinate is x, y, z. So dx, dy, dz, you will move to point Q. So point Q lies along the r cap. So this change will be dl vector because we have changed x, y, z by elemental amount of change dx, dy and dz. So now can you write dl vector in component form? Dx x cap plus dy y cap plus dz z cap. So you must remember dl vector in Cartesian coordinate. Whenever we have to find line integral in Cartesian coordinate, we will use this as a dl vector. Now we can further visualize this symmetry. So let us consider an elemental cube. Whenever I say elemental, means its sides are dx, dy, dz, very small. So this is x cap, this is y cap, and this is z cap. And this is our point P. Point P is here. Means you have drawn an elemental cube around point P. So you are at point P. This corner is point P. And what is the coordinate of point P? X, Y, Z. This coordinate P is this point. So its coordinate is X, Y, Z. Draw this figure. Point P coordinate is X, Y, Z. Now you have to show point Q on this elemental cube. So this is X, Y, Z. X changes to dx. So I am writing this change is dx. This change will be dy, and this change is dz. So this will be point Q. This will be the point Q. So if you connect point P with point Q, this will be your dl vector. This will be your dl vector. Just connect point P with point Q. So that will represent your dl vector. Now you can visualize this dl in component form. So dl, how you will write dl vector? Just like r. So dl has three components: dx, dy, dz. So that is dx x cap, dy y cap, dz z cap. So if you can visualize this elemental cube, you can easily see dl in its component form. Clear? So draw this picture. So this is an elemental cube. We call this as an elemental cube. Elemental cube. So you know from elemental cube you can write the dl vector. We can also write volume element. What will be volume element? D tau. So if you just this is the volume of the elemental cube. So this will be given by dx dy into dz. So in Cartesian coordinate system, volume element is dx, dy and dz. This will be the volume element. Because it's a cube, so if you multiply sides of the cube, you will get volume, and it's an elemental cube, so that volume is elemental volume. If you integrate over this, you will get the volume of the cube if sides are given. Clear? So we have seen how to write dl vector in Cartesian coordinate, how to write d tau. Now we will see how to write area element. So area element you have to write on a particular surface. Now surface may be open or it may be closed. So how you will differentiate between an open surface and a closed surface? If you have any volume that is surrounded by closed surface, whenever you have volume, that will be surrounded by closed surface. And when you have an open surface, that will be surrounded by closed lines. Closed lines. So we will see how to write area element. Area element. dA vector. So this we have to write on closed surface, and open surface. Closed surface, whenever you have a volume, that will be surrounded by closed surface, and an open surface is surrounded by closed line. So we will first see closed surface. Closed surface. So in Cartesian symmetry, best example is cube. It's a cubical volume. So let's draw a cubical volume. It's a cube of side A. In Cartesian symmetry, we are talking about a cubical symmetry. In a spherical polar coordinate, we will talk about symmetry of a sphere. Cylindrical symmetry of a wire. So let's consider this cube. This is x cap, this is y cap, and this is z cap. This point is the origin. This is the origin whose coordinates are 0, 0, 0, and their sides are A. Sides of the cube is A, and this corner is the origin. So this volume is surrounded by how many surface? 6 surface. So if you consider all 6 surface, so then it forms a closed surface. So this particular volume is surrounded by 6 surfaces, and we have to write area element on each surface. So let us first consider surface 1. Surface 1 is, I am taking this particular surface. This is the surface 1. So this is the plane that is perpendicular to x-axis. Surface 1 is what? This plane is perpendicular to x-axis. So what will be fixed on this surface? X. So this is x is equal to A surface, because x is fixed over it. And if you draw an elemental area here like this, what will be variable? Dy dz. So this side is dy and this side is dz. So area element is given by magnitude is dy dz. If you draw some area element, one side is dy, another is dz. So that will give you dy dz. And what will be direction? Now direction on the closed surface, you can write direction of, you have to remember this point, direction of dA on closed surface is perpendicular to the surface and pointing outwards. This will be the direction of dA. Perpendicular to the surface, pointing outward direction. For example, if this is the cube, so this direction is outward direction. So this is the x cap direction. X cap is outward direction. Yes or no? X cap is the outward direction. If this is the cube, so this is the outward direction. Surface 1. Now opposite to this, you have surface 2. So what will be fixed for surface 2? Yes, it's a x is equal to 0 because this is the origin. So this plane is at x is equal to 0. So that's why it is x is equal to 0 plane. And what will be dA over it? Magnitude will be dy dz. Same because perpendicular to x-axis, variable will be y and z. And what will be direction? Away from the surface. So this direction is minus x cap. Because if this is plus x cap, opposite direction is minus x cap. So dA over this is given by minus dy dz x cap. X is equal to a, x is equal to 0. In same way, this is y is equal to a, y is equal to 0. This is z is equal to a, z is equal to 0. So let's write. Now I am taking this to be surface 3. This direction is y cap. So surface 3 is y is equal to a. And dA will be dx dz y cap. Y is equal to 0. Fourth surface is y is equal to 0. Direction is minus y cap. So this is minus dx dz y cap. Then this is fifth surface. This direction is z cap. Z is equal to a and dA will be given by dx dy and z cap. And this is sixth surface minus z cap. Z is equal to 0 minus dx dy. So on each surface, you can write the area element. Direction will be perpendicular to the surface, pointing outward. Must remember this, pointing outward direction, not inward. Whenever it is closed surface. Clear? Second is open surface. How to write area element on open surface? So I am taking one example of an open surface. This is the rectangular surface, and that will be surrounded by closed line. This is a rectangular surface, and that is an open surface. And whenever there is an open surface, that will be surrounded by closed line. Just see, this is surrounded by a closed line. Clear? So how to write area element on open surface? So again we will write this. This is the, what will be this length? dy. What will be this length? dz. Because this is in yz, so this is again x is equal to 0 plane. So this is x is equal to 0 plane. dA will be given by magnitude is dy by dz. Magnitude is dy by dz. But what will be direction? You can't use same definition. Away from the surface. This is also away from the surface. Opposite direction is also away from the surface. So direction of dA on open surface, you have to use again right hand rule. This is for direction of dA. Direction of dA on open surface. On open surface. Direction of dA on open surface. So again you have to use right hand rule. Curl your finger in the direction of this closed line. Whenever open surface is given, they will always specify this closed line, whether you are moving in anti-clockwise or clockwise. So use your right hand and curl your fingers in the direction of closed line. Then thumb will give you direction of dA. So according to right hand, this direction will be x cap. So dA is given by x cap. If for same rectangular surface, if DL is opposite to this, then this direction will be in the minus x cap direction. So if you have to write dA over this surface, this is minus, you have dy dz, and then it is x cap. So that is the direction of dA on an open surface. Just use right hand rule. Anti-clockwise, this is x cap, and in clockwise you have minus x cap. Use right hand rule. Don't take it as positive or negative.
Any surface inside the tube will be a closed surface.
No, any, if you have a volume, cubical volume, then outer surface, you are considering surface means outer surface. And if you consider all the surface, then it will form a closed loop.